And all of this as North is ready to launch a nuclear test at its nuclear test site. The 38 North Monitoring Group reported on Wednesday.
In a high school classroom in northeast China, students bent over their exam papers, pencils scratching against paper in focused silence. Then, without warning, the ground beneath them began to shake. Desks rattled, pencils rolled, cracks spiderwebbed across the playground outside. But this wasn't a natural earthquake. 1,500 miles away, seismometers around the globe suddenly lit up like Christmas trees. From Tokyo to Stockholm, from Washington to Moscow, scientists stared at their instruments in disbelief. The readings were off the charts. A magnitude 6.3 earthquake had just originated from the heart of North Korea. But here's what made their blood run cold. This wasn't tectonic. This was artificial. Someone had just detonated the most powerful nuclear weapon in North Korean history. And in doing so, they had literally moved a mountain. Welcome to the story of Mount Mantapsan, the mountain that became ground zero for one of the most dangerous nuclear experiments of the 21st century. A story of scientific ambition, geopolitical brinkmanship, and a sleeping giant that may have been awakened by humanity's most destructive force. Deep in the mountains of northeastern North Korea, shrouded in secrecy and surrounded by military checkpoints, lies the Punggye-ri nuclear test site. For over a decade, this remote location has been the stage for some of the most consequential explosions in modern history. Mount Mantapsan rises 7,200 feet above sea level, its granite peaks cutting through the morning mist like ancient sentinels. But beneath this seemingly peaceful exterior lies a labyrinth of tunnels, an underground network that would make even the most seasoned mining engineer marvel. The North Korean military had spent years carving these passages deep into the mountain's heart. 3 main arteries, the South Portal, the East Portal, and the West Portal. Each tunnel snaked through solid rock for thousands of feet. Hook-shaped passages designed with one terrifying purpose, to contain the uncontainable. Imagine, if you will, the scene on that fateful September morning. Deep underground, 1,470 feet below the mountain's peak, technicians made their final preparations. The device they were about to detonate wasn't just another nuclear bomb. This was a thermonuclear weapon, a hydrogen bomb, with the potential to release energy equivalent to 250,000 tons of TNT. To put that in perspective, the bomb that destroyed Hiroshima was 15 kilotons. This weapon was potentially 16 times more powerful. At 12:36 p.m., the world changed. In an instant, the nuclear device vaporized everything within a 164-foot radius. An underground chamber roughly the size of a football stadium simply ceased to exist. The granite that had stood for millions of years was instantly converted to plasma, hotter than the surface of the sun. But the destruction didn't stop there. The shockwave radiated outward, fracturing rock across a zone nearly 1,000 feet wide. The mountain itself, this ancient, immovable giant, was lifted 6 feet into the air and pushed outward by 10 to 13 feet. Picture that for a moment. An entire mountain, weighing billions of tons, physically moved by human hands. Wang Nayan, a scientist from the China Institute of Atomic Energy, would later describe the scene with chilling precision. It was like watching the Earth itself convulse. The mountain rose, expanded, then collapsed back on itself, forever changed. The aftermath was immediate and terrifying. The explosion triggered landslides across the test site. Satellite images captured before and after shots that looked like scenes from an apocalyptic movie. Where once there had been pristine mountain slopes, now there were scars of displaced earth and fractured rock. But perhaps most ominously of all, the mountain settled 20 inches lower than it had been that morning. The peak that had stood unchanged for millennia was now permanently shorter, a testament to the awesome and terrible power that had been unleashed within its depths. The explosion sent shockwaves far beyond North Korea's borders, both literally and figuratively. In Chinese border towns, families eating lunch suddenly found their tables and chairs dancing across the floor. Office workers in Yanji evacuated their buildings as windows rattled and walls swayed. The high school students we met at the beginning of our story? They were dismissed immediately when that crack appeared in their playground, a physical manifestation of the nuclear violence occurring just across the border. This wasn't just a local phenomenon. The seismic waves traveled across continents. Dr. Liu Junqing from the University of Science and Technology of China had been monitoring North Korean nuclear activity for over a decade. His team, using data from 112 earthquake monitoring stations, didn't just detect the blast. They pinpointed its exact location within meters. We've been tracking every North Korean nuclear test since 2006, Dr. Liu explained to reporters. But this one was different. The seismic signature was unlike anything we'd seen before. It wasn't just bigger, it was fundamentally more destructive. The international response was swift and unanimous. World leaders condemned the test in the strongest possible terms. But behind the diplomatic rhetoric, scientists around the globe were asking a more pressing question. What had North Korea just done to one of the most geologically sensitive regions on Earth? 72 miles southwest of Mount Mantopson lies another peak, Mount Paektu, an active volcano that has remained dormant since 1903. To most observers, this might seem irrelevant. But to volcanologists studying the region, Mount Paektu represented a sleeping dragon that had just been violently shaken. Dr. James Hammond, a seismologist who had been studying the region, made a disturbing discovery. The shock waves from the nuclear test had traveled directly through the Earth's crust to the magma chambers beneath Mount Paektu. Using sophisticated mathematical models, his team calculated that the explosion had increased pressure in the volcanic system. Imagine a bottle of champagne that's been shaken, Dr. Hammond explained. The pressure builds, and it only takes the smallest trigger to cause an explosive release. The North Korean nuclear test may have provided exactly that kind of trigger. The implications were staggering. Mount Paektu's last major eruption in 946 AD was one of the most powerful volcanic events in recorded human history. It ejected material across thousands of square miles and affected climate patterns across the northern hemisphere. If the nuclear test had indeed destabilized the volcanic system, the consequences could affect not just North Korea, but China, South Korea, Japan, and beyond. But the immediate concerns were even more pressing. Chinese scientists had detected something that made their blood run cold. In the months following the September test, satellite imagery revealed a disturbing truth. Mount Mantopson was literally falling apart. Chinese researchers coined a term that had previously only been used for Soviet nuclear test sites: tired mountain syndrome. The repeated nuclear explosions had fundamentally altered the mountain's internal structure. Rock that had been compressed for millions of years was now fractured and unstable. Entire sections of the mountain were at risk of catastrophic collapse. The mountain is exhibiting clear signs of structural fatigue, explained Dr. Wen Lianjing, a geologist who had been studying the site. Multiple underground explosions have created a network of fractures that compromise the entire peak's integrity. The most terrifying scenario wasn't just the collapse itself, it was what might be released in the process. Years of nuclear testing had left radioactive materials embedded in the mountain's fractured rock. If the mountain collapsed completely, these materials could be released into the atmosphere, creating a radioactive cloud that could drift across international borders. Wang Nian's warning was stark. If the mountain collapses and a hole opens up, everything the rocks were holding inside will burst out like steam coming out of a pot when you take the lid off. The international community held its breath, waiting to see if one of humanity's most destructive experiments had created an environmental disaster of unprecedented proportions. For 8 months after the September test, the Earth continued to tremble. While the world's attention had moved on to other crises, seismological stations in China, South Korea, and the United States quietly detected something extraordinary. Between September 23, 2017 and April 22, 2018, more than 10 aftershocks rattled the test site area. Dr. Paul Richards from Columbia University's Lamont Doherty Earth Observatory had seen many nuclear tests in his career, but nothing like this. The pattern of aftershocks suggests that the September test fundamentally disrupted the geological stability of the entire region, he explained. The Earth was still trying to find its equilibrium 8 months later. Each tremor, while relatively small, ranging from magnitude 2.1 to 3.4, told a story of continued instability. The mountain was settling, adjusting, groaning under the weight of its own damaged structure. Meanwhile, Chinese authorities conducted intensive monitoring along their border with North Korea, collecting air and soil samples to test for radiation. The results were cautiously reassuring. No immediate radiation threat was detected, but the long-term implications remain deeply uncertain. When the full scope of the September 2017 nuclear test became public knowledge, the world's reaction was one of horror and fascination in equal measure. Social media exploded with satellite imagery comparisons showing the before and after shots of Mount Mantapsan. Environmental groups pointed to the test as evidence of humanity's capacity for geological vandalism. The image of a mountain physically moved by human technology became a powerful symbol of our species' ability to alter the planet itself. In South Korea, families living just 200 miles from the test site organized protest rallies. "They're not just threatening us with nuclear weapons," said Park Min-jung, a mother from Seoul. "They're literally breaking the earth beneath our feet." Environmental scientists around the world began asking uncomfortable questions about the broader implications. If a single nuclear test could move a mountain, crack the earth for hundreds of square miles, and potentially trigger volcanic activity, what were the cumulative effects of all nuclear testing throughout history? Dr. Lynn Sykes, a seismologist who had studied nuclear testing for decades, put it bluntly. The September 2017 test represents a threshold moment. It's not just about nuclear weapons anymore, it's about our capacity to destabilize the very ground we stand on. On May 24, 2018, in a carefully choreographed display for international journalists, North Korea demolished the tunnel entrances to the Punggye-ri test site. 20 reporters watched from 1,640 feet away as explosions sealed the portals that had been used to conduct 6 nuclear tests over 11 years. The theatrical destruction was meant to signal North Korea's commitment to denuclearization. But as the dust settled and the journalists departed, a more sobering reality remained. The mountain would never be the same. Today, Mount Mantapsan stands 20 inches shorter than it did before that September morning. Satellite monitoring continues to detect ongoing structural instability. The tired mountain syndrome that scientists identified shows no signs of improvement. Perhaps most haunting of all, Mount Pektu, the sleeping volcano 72 miles away, continues to show signs of unrest. Volcanologists maintain their vigil, knowing that the next eruption, if it comes, may have been triggered by humanity's most destructive experiment. The story of Mount Mantapsan serves as a stark reminder of our species' awesome capacity for both creation and destruction. In our pursuit of the ultimate weapon, we didn't just split atoms. We moved mountains, cracked continents, and possibly awakened forces that had slumbered for over a century. The mountain remembers what we did to it that September day. And in its continued trembling, its ongoing instability, and its permanently altered profile against the sky, it serves as a monument to a moment when humanity proved it could literally move the earth. But at what cost? And what ancient forces might we have disturbed in our demonstration of power? Only time and the restless earth beneath our feet will tell. Don't forget to like this video if you learned something new and subscribe for more stories about the hidden forces that shape our world. What do you think about North Korea's nuclear testing program? Share your thoughts in the comments below.